Well. Hello, welcome, ARP. This is the description of the final assignment in the first semester, the third one. You know that the assignment, I've already told you that it will be completely cooperative. So you will work in groups. Maybe one only group or two groups, we will decide after, not important. You can start all together in one big group. Let me so I want to stay here just to watch you. Final assignments. Cooperative. That means that you will act you're about 30, more or less. 30, I assume that 30 is the number of students that delivered the first and second assignment or they will do. So I assume that the students in the exam in January and February will be about 30. So we will decide after if to carry out the cooperative experiment in just one group, 30 students. It's fairly possible, or to divide in two groups, maybe depending on the date of the exam you choose. So we will decide later. So the idea, you start in one team in the sense that one group working together, and you will start in the Tuesday class tomorrow just to discuss how to organize yourself. The organization, design, coding is your responsibility. Your responsibility. It's up to you. You decide the way, if you organize in a group with the team leader or not. You do what you want. You need simply virtual machine. Every one of you will work on her own virtual machine, Azure virtual machine. So the software you run will run on the virtual machine, and all virtual machines will be connected together. I will show you. And you need coding, of course. The idea is that the algorithm you have to implement is very simple, and you can reuse as much as possible code or principle of coding that you have already used in the first and second assignment. The demonstration or test or final test to be decided. I will organize how to do that using also the assistant teacher that you don't know already, but you will know in the last phase, because he will cooperate in evaluating your assignment. And so we will decide how to do that. If we do all together just in one day or in 2 days, or that doesn't matter. In any case, you have to upload code on the as it has been done for the first and the second assignments in Aula Web. So personal uploading, even if you are working in groups, of course. But I assume that each code may be slightly different. It doesn't matter. upload your code, just like assignment 1 and 2. Tomorrow you start. I will give you a room, and so you will start discussing how to organize yourself, and maybe also some technical matter on the design of the system. But probably I suggest you start organizing yourself as a team. So usually a team gives positions to some of the person of the team. A team leader, probably. A team leader is not the chief of everything or the one who does all the job, but just to take the accounting, all the persons working, and with deadlines, with the scheduling times and everything. And some other groups leaders, smaller groups leader, you decide if you want. I can suggest you how to do that, but it is an experiment of working together. You know that this degree is strongly based on work, and on cooperative work. So it's a skill that we want you to learn. Well, that's all. Let me try to just schematize which is the game that you have to implement. Read the document in our web, but I will just summarize in a few words. Let me stop a while. So first, let me clean all this so we can start. Which is the aim of that game? Well, I write here just maybe you are 30 or 15, I don't know. Let me think that you are just 4. Doesn't matter, of course. These are 4 virtual machines. The virtual machines, there will be a table with all virtual machines. You have to organize this table. IP address. You can use the IP address as an identifier of the node, or you may use the position on the array in which you have the all the IP addresses. It doesn't matter. So you have to identify nodes. So nodes are identified. I will use number here. The aim of the game is similar to in a sense, to the first assignment aim, as to say, to measure bandwidth or measure times. We'll measure times of transmission. So it's a sort of it's a measurement of the data transfer speed in the network. Probably all virtual machines are on Azure, so they will communicate each other. Probably they are close each other, and times will be short. But in any case, you have just to measure like the virtual machine were real machines all over the world. So the first step is, suppose you are 4. You toss a coin and you decide that one machine, we don't know which, for example, number 3, is what is called in the notes that you can read in the specification, the turn leader, because it runs in turns. The first turn, it just start communication, and randomly it decides a new order for this table, and decides to communicate with one and chooses one of the nodes to send a message. For example, this one, suppose this is number 2, and sends a message. At this point, number 2 executes exactly the same algorithm that has been executed by number 3. So it decides a new the aim is just to send another message, so I will show you the content of the message, choosing randomly. So in also 2, the node number 2, it doesn't follow the order of execution decided by 3, because it chooses another order. Randomly, it communicates with node 0, for example. Node 0 decides randomly to communicate to another node, discarding all the nodes discarding, for example, suppose that randomly it tries to communicate, choose another color to communicate with 2. No, it's wrong, because 2 has already been visited. Maybe it chooses 3, that is the turn leader. No, because it already been visited. So in that case, the only one that is left, of course, is number 1. Number 1 in turn chooses a few choices. It has to communicate back to number 3. So when a node says that I'm the last one, I send back the message to number 3, and this the end turn. End turn. During this communication, which are the exchanged data? It's a record or a struct in C language, in which you accumulate several information. The sender, in the case of the first message, of course, the sender is number 3 at the beginning. The sender says the time, the reception time of the last message received, that when first the number 3 starts as 0 here, because it didn't receive anything. And the sending instant. I don't know which is. And so this is the message that 3 sends to 2. 2 says I am the sender. 2, my receiving time, the time I have received the message from 3, and the sending time, and so on, and sent to in that case to 0, and so on, and so on, and so forth, until all the message is with all the element of this structure are an element filled by the node that puts the additional information. So my name and the time of the reception and sending to the next node. And the end at the end of the turn, the turn leader 3 have it as a statistic, no, not as a statistic, as a recorded all the times in the transmission. You repeat 10 times, and so you can compute on 10 times of the games, and every time the order of transmission is different, because each node randomly chooses the next node randomly. So you have 10 a complete visiting of the network, or the network of nodes, but with different paths. And so you have you can decide which is the statistics of the transmission in terms of speeds, or we will see on bandwidth. We will decide after. Is a detail. And so the turn is completed after 10 the turn, yes, 10 times. It is carried out 10 times, and you do 10 times by choosing this 10 times. So 10 times with the turn leader 3, because you randomly have chosen the 3, and 10 times choosing another turn leader. That's all. At the end, the results, the 10 team turn leaders will send their 10 statistics to a central server. The 10 turn leaders send statistics to a server. The server will be defined, and it's not up to you, it's our responsibility. To be defined. So the format of data to be sent and the IP address, so in a sense the protocol for sending those data and the IP address to send of the server will be communicated after. So it's not important now, but soon we will tell you. So that's your job. Read carefully the the specification in our web, and we can discuss them. I've discussed it with the coordinator, so the document you read is the version 3, but we can upgrade it with the version 4 or 5 and so on, if you find that there's something to be detailed differently or some errors and so on. So we also work together in defining specifications, refining specifications. And starting from tomorrow, in any case, we will have possibility of meeting. We will decide a schedule. Well, you suggest which is the best thing to do. If we want to schedule from now just days in which and times in which we may have a meeting all together, if you are interested in, or you ask and I will provide you a meeting. I will be at home all the December and January, so I have no problem in providing some meetings. Okay, that's all. Thank you very much. Meet tomorrow at 3 o'clock. Bye. Thank you.